Well, it had to happen. Now we are on to division with exponents. Let me just say that division is the primary cause for all breakups. Ha, ha, ha. Division, breakup, get it? Division with exponents. It's the opposite of multiplication. So let me revisit multiplication just for a moment. And what we learned with multiplication with exponents is that x to the a times x to the b equals x to the a plus b. You add the exponents together when the bases are alike and you are multiplying. Division is exactly the opposite. The rule for division is x to the a being divided by x to the b equals x to the a minus b. The one on top subtracted by the one on bottom. A minus b. So let's see how that's going to work. So if I have something like x to the fourth being divided by x squared. The rule says you take the exponent of the one on top and subtract the exponent on bottom. So it's x to the 4 minus 2, which would equal x to the second power. Now let's examine this and see why that is. Starting with x to the fourth power in the numerator. That means there are 1, 2, 3, 4 x's in the numerator. X squared in the denominator. 1, 2. Now because everything is being multiplied in the numerator and the denominator, you can go ahead and divide the like items on the top and the bottom. In other words, cancel them out. They don't really go away, they just turn into 1. X divided by x is 1, so we can mark those out. Here again we have another pair of x divided by x is 1. The bottom goes completely away, so we replace it with a 1. And on top we have x times x, which is x squared. X squared divided by 1 is simply x squared. But let's flip this around. Let's do x squared being divided by x to the 4th. What happens then? Well, again, the rule is the one on top minus the one on bottom. This would equal x to the negative 2. Yesterday we practiced negative exponents. Bells are going off in our head right now. Ding, 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 ding. We have a negative exponent. This is on the wrong side of the divide sign. To correct it, we need a division. The x's are going to go on the bottom because they have a negative exponent. The exponent will turn into a positive when it gets where it's supposed to be. There's nothing remaining on the top, so we put a 1 there. We can also see it like this. The same example here. You have x times x on top, x, 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 x on bottom. The first two cancel out. That leaves 2 x's on bottom, x times x, which is x squared. Nothing on the top, so we put a 1. You're probably thinking, that seems pretty easy. It is pretty straightforward. Let's make it a little bit more involved now. Suppose we have 4 x squared y to the third being divided by 3 x y to the 5th. Okay. Here's what I do. When I analyze, first I take these two numbers and I put them in my calculator. 4 divided by 3, math, enter. What that tells me is that this is a fraction that does not reduce, and so I will still have a 4 on top, a 3 on bottom. If it reduced, it would show up in your calculator, and you would write it the way that it says in your calculator. Now I go ahead and I continue analyzing. I have x's. Power of 2 on top, power of 1 on bottom. There are more x's being multiplied on the top, so my x's in my final answer is going to be on the top. So the x's go on top. And now I do the subtraction. 2 take away 1 is 1, so it's x to the first power. Now on to the y's. I have 3 y's being multiplied on the top, 5 on the bottom. There are more y's on the bottom, so the y's are going to end up on the bottom of the fraction. And now I do my subtraction. It's just, if you do it this way, it's just the biggest number minus the smaller number. 5 take away 3 is 2. And that's the final answer. Now let's again take a look and see why this is. Alright, so going back to the original problem. 4. Now we have 2 x's and we have 3 y's. 1, 2, 3. That's the numerator. On the bottom we have 3. We have just 1 x on the bottom. We have 5 y's. 1, 2, 3, 4, 5. Now, when we go to cancel, the 4 and the 3 will not cancel out. It cannot be reduced in any way. It's just 4 divided by 3. Mark out this pair of x's. That leaves 1 x on the top. Mark out the y's. Marked out 3 pair. That leaves 2 y's being multiplied, and they're on the bottom. That's y to the second power. Same answer. Some of you maybe prefer doing it this way. Some of you, the subtraction is not a problem for you, and you will prefer to do it this way. Whichever way you do it, you can reach the same correct answer. All right, I'm going to try and turn this piece of paper over, and let's examine some other things that we could run into. That's ugly. Okay, so 3 over 6, x to the negative 2, x, y to the third, y to the fifth, z to the negative 3. Negative 2, positive 3. Positive 5, negative 3. So there's a lot going on right here. My suggestion would be, because you see these negative exponents, take care of them first. Rewrite this expression with everything where it's supposed to be to begin with. So we have 3 over 6. These x's are to the second power. They're going to go down to the bottom. X squared, x. That takes care of the x's. Y to the third, y to the fifth, both positive, so they don't move. And z to the negative 3. That means it needs to go to the top. That takes care of everything. Now we're ready to do the division, what there is of it. Okay, so we start with these two numbers, 3 divided by 6. In your calculator, the calculator tells you that that is 1 over 2. If it's 1 in the denominator, you might want to wait. If there are other things in the denominator, then you won't need to write the 1. It's not a bad idea to write it to begin with. You can always continue on one more step and write your final answer. Okay, so that takes care of the 3 and the 6. Now we come to the x's. There are no more x's on the top to cancel any of these out. So it's x squared times x to the first. So x is to the 3rd power. Now we move on to the y's. Y to the 3rd on top, y to the 5th on bottom. My y's are going to end up on the bottom, and it's 5 take away 3. And then finally the z's. There should be a positive 3 now. We moved the z's to the top because they had a negative exponent. Now they are on the top with a positive exponent. There are no more z's to cancel anything out with on the bottom. So z to the 3rd goes on top. And we've got the y's, we've got the z's. Everything is taken care of. So the final answer is z to the 3rd over 2x to the 3rd y squared.